Hi everybody. Well, let's begin our discussion over the questions on the chapter statistics. First question for 2 marks says that for a group of 200 candidates, the mean and standard deviation were found to be 40. Basically, it's just the mean given, not the standard deviation. Later on, it was found that the score 43 was misread as 34. Find the correct mean. So, the group is of 200 candidates. That means the total number of observations given to you is 200. So, I will say N stands for total number of observations that is given to you as 200. The mean is 40. Mean right now is 40. Fine. It was found that the score 43 was misread as 34. One of the scores was 43, which was misread as 34. So, there are 200 scores basically. Out of that, one score was 43, which was misread as 34, and with that 34 as one of the observations, the mean calculated was 40. So, we know this is the wrong mean. This is the mean which is evaluated when one of the observations was kept as 34 rather than 43. Correct is 43, it was misread as 34. So, 40 is the mean which is evaluated when one of the observations out of the 200 observations is 34. So, if I talk about general mean formula, what is that? It is summation xi, I varying from 1 to n, n is the total number of observations which is 200, whole upon n, that is 200. Right now it is given to me that mean is 40. So, this is summation xi, I running from 1 to 200 whole upon 200, which implies if I talk about sum of all 200 observations, out of which one of the observations was 34 instead of 43, that is coming out to be 40 into 200, which is 8000. This is the incorrect summation of the 200 observations, because one of the observations is actually wrong in here, that is 34. So, what would be the correct summation? Correct one would be when the observation xith, or basically the ith observation, which is 34, is replaced by 43, and then the sum is evaluated. So, basically I will take the incorrect sum. I will take the incorrect sum. This is the sum of 200 observations when one of them was 34. From it I will remove 34 and add 43. This is going to give me the sum of 200 observations when one of them is not 34 but 43. It is replaced by 43. So, you basically get 8000 minus 34 plus 43, which gives me 8009. If this is the correct summation, then correct mean is equal to correct sum of observations upon total number of observations. Right? Formula is the same. This is 40.045 is your very answer. Moving to the next question, we have the scores of a batsman in 10 matches are given to you. Compute summation di, where di is representing deviations of observations from the assumed mean. Now, when I am talking about the assumed mean, I actually have to assume that as one of the xi's, such that when you calculate deviations of any xi from that chosen xi, the answer comes out to be a very, very small quantity. So, what I do is I write xi's as 38, 70, then 48, 34, 42, 55, 63, 46, 54 and 44. I take that value as the assumed mean on the grounds that when I calculate deviations of any xi from that chosen xi which I am taking as the assumed mean, the answer come to be very, very small. Here I can see that all the numbers are somewhere nearby close to 48, so I choose 48 as my assumed mean. Fine. If I have chosen 48 as my assumed mean, because every xi is very, very close to 48, as you can see, Next would be calculating deviations of xi from the assumed mean. 38 minus 48 gives me minus 10. 70 minus 48 gives me 22. 48 minus 48 gives me 0. Then 48 minus 34 gives me 14, or I should say 34 minus 48 gives me minus 14. 70 minus 48 gives me 22, 48 minus 48 gives me 0, 34 minus 48 gives me minus 14. Then 42 minus 48 gives me minus 6. 55 minus 48 gives me 7. Then 63 minus 48 gives me what? 63 minus 48? 63 minus 48 gives me 15. Then I have 46 minus 48, this gives me minus 2. Then 54 minus 48 gives me 6. And then 44 minus 48 gives me minus 4. Let's check. 38 minus 48 gives me minus 10. 70 minus 48 gives me plus 22. 48 minus 48 gives me 0. 34 minus 48 gives me minus 14. 42 minus 48 gives me minus 6. 55 minus 48 gives me plus 7. 63 minus 48 gives me positive 15. 46 minus 48 gives me minus 2. 54 minus 48 gives me 6, and 44 minus 48 gives me minus 4. Now in here when I have calculated all these deviations, now this actually has to be 7. This is 7. In here when I have calculated all these deviations, when I talk about di, this is my di, and I am interested in evaluating summation di I running from 1 to 10, because these are 10 observations. That means I am interested in evaluating this. What is this? This is the sum that you obtain when you add all of these. Right at the end you can write this summation di I running from 1 to 10, and this sum when you evaluate it comes out to be 14. So your answer is actually 14. Sum of all deviations of individual observations from the assumed mean is coming out to be 14. Clear? Which we are denoting by di. Two plants A and B of a factory show following results about the number of workers and the wages paid to them. Okay. Number of workers 5,000, 6,000 in plant A and plant B. Average monthly wages in plant A and plant B is exactly the same. Average is the same. Variance is given as 81 and 100 in plant A and plant B respectively. In which plant A or B is there greater variability in the individual wages? If you can recall, if the average or the mean is the same, it is the standard deviation which is the alone decider in actually giving you the very conclusion about variability. Which has greater variability, which has lesser variability is just going to be concluded with the help of standard deviation, because the mean is given to be the same. Here average monthly wages are given to be the same. So I will only be interested in calculating the answer to this query by evaluating the standard deviation corresponding to both the plants. So variance in plant A, variance in plant A is 81. Therefore, standard deviation in plant A is positive square root of variance, that is 9. Variance in plant B is given as 100. This is actually sigma square, and this is what I am calculating as sigma. So let me say sigma 1 square, this is sigma 1, this is sigma 2 square, and therefore standard deviation in plant 2 or in plant B is positive square root of 100, which is 10. This is my sigma 2. Clearly, as average monthly wages, as average monthly wages in both plans are same. Therefore, standard deviation happens to be the sole decider in concluding about variability. And standard deviation of plant A clearly is strictly less than standard deviation of plant B. This implies what? Plant B. In plant B, there exists higher variability in individual wages. Is it clear? Because when the mean is the same, this average is the same, in that case, that particular portion which has greater standard deviation possesses greater variability, is more variable, is more dispersed, is more scattered. Whereas the one with lesser standard deviation is more stable, it is less variable, right? Therefore, we are able to conclude that in plant B, the variability of individual wages would be more than here. Clear? It would be greater in plant B. Next we have the scores of a batsman in 10 innings are given to you like this. Find the mean deviation about median. So, you should be able to recall the concept regarding finding mean deviation about median. This is my ungrouped data given to me. So, what is the formula to evaluate mean deviation about, not the mean but the median for an ungrouped data? It is summation mod of xi minus the median whole upon total number of observations. I running from 1 to total number of observations. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, there are 10 observations. First of all, we need to evaluate the median. How do you calculate the median? Here, first of all, arrange it in the ascending form. You have 34. After 34, you have 38. After 38, you have 42, 44, 46, 48. 42, 44, 46, 48, and then you have 54, 55, 63. 54, 55, 63 and then 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 observations covered in ascending form. N is equal to 10, which is even. Therefore, arithmetic mean of n by 2 and n by 2 plus 1. Arithmetic mean of 5th and 6th observation is my median. What is my median? What is the 5th observation? 1, 2, 3, 4, 5. When you have arranged in the ascending form, then you check out the 5th and the 6th term. 5th is 46, 6th is 48. Taking their arithmetic mean means adding them, dividing by 2, you get 47 as your very median. The moment median is evaluated, now it's time to calculate the mean deviation. You have 38, 70, 48, 34, 42, 55. After that, you have 63, 46, 54 and 44. Clear? Calculate xi minus the median with mod, absolute value. So, now I have 47 minus 38. When you calculate 47 minus 38, you get what? You have 47 minus 38. This gives you 9. Then you have what? Because it's absolute value, I am not plugging in the minus sign. 70 minus 47 gives you 23. 48 minus 47 gives you 1. Then 47 minus 34 gives you 13. 42 minus 47 gives you 5. Then 55 minus 47 gives you 8. Then 63 minus 47 gives you 16. 46 minus 47, 1. 54 minus 47 gives you 7, right? And then 44 minus 47 gives you 3. When you evaluate the sum, what this comes out to be, let's see. I want the sum of this, and I would be dividing it by total number of observations, which is 10. This sum, when you evaluate, it comes out to be 86, and therefore your mean deviation about median is nothing but 86 upon 10, that is 8.6. Is it clear? This, once you've evaluated, the sum comes out to be 86. This is nothing but representing summation mod of xi minus the median. And if this is 86, numerator is 86, denominator is 10, your answer is 8.6. Is it clear? Next we have calculate the mean and standard deviation of first n natural numbers. Okay, that means first n natural numbers are given to me as n individual observations. I need to calculate its mean and standard deviation of first n natural numbers. Basically in here, when I am calculating the mean is x bar given as summation xi, I running from 1 to n, whole upon n. Now x1 is 1, first natural number, x2 is 2, x3 is 3, xn is n. These are my n individual observations, my ungrouped data whose mean I need to evaluate. Here you are not supposed to evaluate the standard deviation. This would be then asked for 6 marks. Here you will just be asked the mean for first n natural numbers. So if these are your n natural numbers, these are playing the role of the n observations. If I wish to calculate the mean, how would I do that? Add. So it's 1 plus 2 plus 3 plus n. Sum of first n natural numbers, because these n natural numbers, first n natural numbers are representing my x1, x2, x3 up till xn individual observations, whole upon n. I know sum of first n natural numbers is given by n into n plus 1 by 2, and already this n is over here. So this n cancels out, you are left with n plus 1 by 2. Fine, this is my mean. Let us evaluate the standard deviation as well. How do you do it? Let's see. If I talk about standard deviation, I know how is it evaluated. It is evaluated as 1 by n summation xi square I varying from 1 to n minus 1 by n summation xi I varying from 1 to n whole square. I know x1, x2, x3 up till xn are nothing but 1, 2, 3, 4, 5 and so on till n. So if I am squaring each of the xi's and adding them from 1 to n, that means I am taking 1 square plus 2 square plus 3 square plus and so on plus n square whole upon n. Sum of squares of n individual observations x1, x2, x3 up till xn, that means sum of squares of first n natural numbers 1, 2, 3, 4, 5 up till n whole divided by n minus. What is this? This is the mean. This is nothing but the mean, and mean is coming out to be n plus 1 by 2. So n plus 1 by 2 whole square. I know that sum of squares of first n natural numbers is given by n plus 1, 2n plus 1 by 6. This is my numerator's expression whole divided by n minus n plus 1 by 2 whole square. This cancels out. You have n square minus 1 by 12 as your answer. Is it clear? You have n square minus 1 by 12 as your answer. When you're going to evaluate this, you can even check this. This is very easy. See, you are left with 2n square plus n plus 2n plus 1 whole upon 6 minus n square minus 1 minus 2n whole upon 2. I have just opened up the braces. This is 4. 2 square is 4. So you get 4 into 2, 8n square plus 8n plus 8n plus 4 minus 6n square minus 6 minus 12n. Clear? You had 8n square plus 4n plus 8n plus 4 minus 6n square minus 6 minus 12n whole upon 24. 8n square minus 6n square is 2n square plus 4n plus 8n 12n minus 12n 0, 4 minus 6 is minus 2 upon 24. Take out 2 common numerator and denominator, you will be left with n square minus 1 by 12. Is it clear? After this we have the question. Coefficient of variation of two distributions are 60 and 70 and their standard deviations are 21 and 16. What are their arithmetic means? Now, this is a direct question. If you remember the formula for coefficient of variation, it will be very, very easy for you to evaluate. So, coefficient of variation of first distribution would be what? The standard deviation corresponding to first distribution upon mean corresponding to first distribution into 100. So, sigma 1 is standard deviation of first distribution, x1 bar is the arithmetic mean corresponding to the first distribution. Now, coefficient of variation for the first distribution is given as 60. So, the left hand side is 60, sigma 1, that is standard deviation for the first distribution, is 21, mean I do not know, multiplied by 100. So, you will be getting x1 bar is 21 upon 60 into 100, this cancels out. What are you left with is 35. So, mean of the first distribution is 35. Similarly, coefficient of variation, if I talk about, let us talk about it here itself. If I talk about the coefficient of variation corresponding to the second distribution, it is equal to standard deviation of the second distribution upon mean of the second distribution. So, this is sigma 2 is standard deviation of the second distribution and x2 bar is representing mean of the second distribution. In that case, coefficient of variation is given to me 70 of the second distribution, standard deviation is 16 upon x2 bar into 100. So, from here when you evaluate x2 bar, because that is what we need to do, it comes out to be 16 upon 70 into 100, which eventually gives you 160 upon 7, that is 22.85. Fine. So, this is the very way to evaluate the arithmetic mean from the given coefficient of variation as well as standard deviation corresponding to two distributions. Next we have following values are calculated in respect of height and weight of the students of a section of class 11th. Fine. Here the question actually is trying to ask you which one of them has greater variability, which one of them is actually going to have greater variability. Corresponding to height, we need to calculate the coefficient of variation. Corresponding to weight, we need to calculate the coefficient of variation and then talk about the variability. Is it clear? So, here if I have the mean as well as the variance given, how can I talk about the coefficient of variation? In order to compute the coefficient of variation, we need a standard deviation. Variance of height is given to me, so I will be getting standard deviation of height. Standard deviation of height would be positive square root of variance of height, that is 127.69. And what is standard deviation of weight? This comes out to be 11.3, and standard deviation of weight is positive square root of 23.1361. This comes out to be 8.61. This is standard deviation of height, this is standard deviation of weight. What is coefficient of variation in height if I wish to evaluate? It is, this is sigma 1, This is sigma 2. Sigma 1 upon x1 bar into 100. This is 11.3 upon mean. What is the mean? Corresponding to height, it is 162.6. So I am taking this as x1 bar and taking this as x2 bar. This multiplied by 100, and when I evaluate coefficient of variation in weight, this is sigma 2 upon x2 bar into 100. Sigma 2 is coming out to be 8.61 upon x2 bar is 52.36 into 100. This, when you evaluate, it comes out to be 6 point something, and this evaluate comes out to be 9 point something. Obviously, coefficient of variation in weight is greater than coefficient of variation in height. That means variability is greater in this section rather than in this section, isn't it? Variability is greater in this section rather than in this section. Therefore, if the question is asking you about variability, the answer is that because coefficient of variation in weight is greater than coefficient of variation in height, that means the data here corresponding to weight is more variable, more dispersed, more scattered, and the corresponding to height, it is more stable, less dispersed. Is it clear? These are the conclusions that you can draw from this data. Next we have find the mean deviation about mean by using step deviation method for the following data. Okay. Find the mean deviation about mean by using step deviation method for the following data. In here, this continuous frequency distribution is given to you. If I need to calculate the mean deviation about mean by using step deviation method, first of all understand mean deviation about mean for a continuous frequency distribution is given by 1 by capital N summation Fi mod of xi minus x bar I varying from 1 to n. Xi's I know are mid values of the class intervals ai to bi, Fi's are the frequencies given to me, capital N is summation Fi I varying from 1 to n, and x bar is what? It is the mean for the given continuous frequency distribution which we need to evaluate by the step deviation method. So mean over here by step deviation method is a plus, you can write capital A, h into summation Fi ui whole upon capital N I varying from 1 to n. Ui is what? The quotient which is obtained when the deviations of xi's from the assumed mean are divided by the common number h. Clear? This h in the case of continuous frequency distribution mostly is taken to be the size of the class interval, because here also you can see each class interval is given of the width size 10. So we take h as 10. Capital N is again summation Fi I varying from 1 to n, calculate x bar, then calculate this, you get your mean deviation about mean. So if I wish to calculate this, see I already have class intervals with me as 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Fi's correspondingly are given to me as 2, 3, 8, 14, 8, 3, 2. I evaluate xi's first, which are mid values of the class intervals. Here it is 15, then 25, 35, 45, 55, 65, 75. Out of these xi's, central value is 45. I take this as my assumed mean and then proceed ahead in calculating the deviations of xi's from this assumed mean. Now 15 minus 45 gives me minus 30, this gives me minus 20, then minus 10, 0, 10, 20, 30. You can clearly see each of the di is divisible by 10, so I take h as 10. And then I obtain di upon 10, that is ui. This is minus 3, then minus 2, then minus 1, 0, 1, 2 and 3. After that I need Fi ui, Fi into ui, 2 into minus 3, 3 into minus 2, 8 into minus 1, 14 into 0, 8 into 1, 3 into 2 and 2 into 3. You can clearly see if you add all of them you are getting a big fat 0. So summation Fi ui is coming out to be 0. Therefore, my mean is actually coming out to be assumed mean, that is 45 plus h multiplied by 0 upon, what do you obtain when you add all of these? You get a 40. Clear? You get a 40. So 0 upon capital N, that is 40. This gives you 45 as your mean. Once the mean is evaluated, let's evaluate mean deviation about mean. Now I want mod of xi minus x bar. So xi minus x bar is this, right? What is a mod of this? So I don't need ui's then. I am wanting mod of xi minus x bar, that is mod di. That would be 30, 20 and then 10 and all of these. When you add, you get 400. Isn't it? Because you want xi minus x bar, xi minus x bar has already been evaluated. What is happening is assumed mean itself is coming out to be x bar. Assumed mean itself is coming out to be my actual mean. If assumed mean would not have been my actual mean, I would have made another column for xi minus actual mean. But right now, because assumed mean in itself is my actual mean, so this column itself I just take the absolute values, the minus signs vanish and my sum comes out to be 400. Is it understood? Now here what basically is happening is this is not 400, obviously you could have checked. When I multiply this by Fi, what do you get? 2 into 30, 3 into 20, 8 into 10, 14 into 0, 8 into 10, 3 into 20, 2 into 30. This comes out to be 400. You can very clearly check. Fine. If this comes out to be 400, mean deviation about mean is coming out to be 1 by capital M, that is 40 into 400. So your answer is 10. 10 happens to be the mean deviation about mean for this continuous frequency distribution. Next we have find the mean deviation about median for the following data. So now the data is of discrete frequency distribution. Again I know that mean deviation about median is given by the same formula, 1 by capital N summation Fi mod of xi minus capital M this time, where capital M is representing the median. Clear? So if we need to calculate the median for a discrete frequency distribution, I know what I need to do. I have 3, 6, 9, 12, 3, 6, 9, 12, 13, 15, 21 and 22, and Fi's are 3, 4, 5, 2, 3, 4, 5, 2, 4, 5, 4, 3. Clear? In order to compute the median, I need to compute the column for cumulative frequency. This is 3, 3 plus 4 is 7, 7 plus 5, 12, 12 plus 2, 14, plus 4, 18, 23, 27, 30. This is my cumulative frequency. Calculate capital N. Capital N is nothing but the sum of these frequencies, which is going to come out to be 30. If capital N, that is sum of all frequencies, how many observations are there? 1, 2, 3, 4, 5, 6, 7, 8. If this is coming out to be 30, N by 2 is coming out to be 15. Search for the cumulative frequency just greater than 15. It is just greater than 15 is 18. Just greater than 15. Cumulative frequency just greater than 15, that is N by 2. And the corresponding value of xi happens to be my median. So here median is declared to be 13. The moment median is declared, now the task is very, very simple. Why? Because I just need to compute mod of xi minus m and then multiply everything with fi. So now I don't need the column of cumulative frequency, right? I have evaluated 13 as my median. So now I will calculate this. 3 minus 13 gives me minus 10. This is minus 7, but I don't want minus sign because I am taking absolute value. 9 minus 13, 12 minus 13, 13 minus 13, 15 minus 13, 21 minus 13. What is 20 minus 13? This comes out to be 8. Fine. Then 22 minus 13 is 9. Fine. The moment you have evaluated this, you will be multiplying fi's with mod of xi minus 13. Multiply fi, 3 into 10 gives me 30, 4 into 7 is 28, 5 into 4 is 20, 2 into 1 is 2, 4 into 0 is 0, 5 into 2 is 10, 32, 27. Add this up, you get 149. Now when you add this up and you get 149, this is basically, what is 149? 149 is nothing but the numerator of mean deviation about median. So mean deviation about median is summation fi mod of xi minus the median. Summation fi xi minus median mod is actually the addition of all of this, which is 149 whole upon the total number of observations, which is nothing but the summation fi, that is 30. You can clearly evaluate this. This happens to be the mean deviation about median. Clear? Next we have find the variance and standard deviation for this given data. So here, if you can clearly observe, calculating variance and standard deviation from actual mean is going to be pretty tedious a task. So let's calculate variance and standard deviation with the help of assumed mean. So if I have xi is with me as 4.5, 14.5, 24.5, 34.5, 44.5, 54.5 and 64.5. And I have corresponding FIs with me as 1, 5, 12, 22, 17, 9 and 4. I prefer to choose the central value 34.5 as my assumed mean, and I wish to then evaluate xi minus assumed mean. This is my DI. Why am I doing this? Because I am interested in calculating the variance by this formula, h square summation fi ui whole square I going from 1 to n whole upon capital N minus summation fi ui I going from 1 to n whole upon capital N, this thing whole square. And obviously standard deviation is positive square root of variance only. So just evaluate the variance, automatically the square root of it will give you the standard deviation. So for this I need ui's. Ui's are nothing but the quotients obtained when di's are divisible by h. H is that common number which is dividing all the deviations. So let's see if we are getting that h or not. Right now I have taken 34.5 as my assumed mean. Calculate xi minus 34.5. 4.5 minus 34.5 gives me minus 30. Then 34 minus 14 gives me 20. Basically 14.5 minus 34.5 gives me minus 20. Then I have minus 10, then 0, then 10, because this is 44.5 minus 34.5 gives me 10, then here 20 and then here 30. You can clearly see I will be taking small h as 10 and obtaining thus ui. Ui is di upon h and h is 10. So this becomes minus 3, minus 2, minus 1, 0, 1, 2 and 3. Now I want fi ui. Fi ui. So 1 into minus 3, 5 into minus 2, 12 into minus 1, 22 into 0, 17 into 1, 9 into 2, 4 into 3. And from here you can obtain summation fi ui, I varying from 1 to 7, because there are 7 observations. Clear? Once fi ui and its sum is obtained, you would want ui square now. You want ui square. If you want ui square, you want what? Ui whole square. If you want ui whole square, these are my ui's. Minus 3 square is 9, then 4, then 1, then 0, then 1, then 4, and then 9. And last column would be fi ui square. Multiply fi with ui square. 1 into 9, 5 into 4, 12 into 1, 22 into 0, 17 into 1, 9 into 4, 4 into 9. Fine. From here you can evaluate summation fi ui whole square, I going from 1 to 7. Let's evaluate capital N. 9 plus 4, 13. 13 and 7 gives you 20. This is 22, 24. 25 and 5 gives you 30. You get 3 plus 1, 4, 5, 6 and 7, 70. So your capital N is actually coming out to be 70. Therefore, variance is what? I had just written the formula h square summation fi ui square I running from 1 to 7 upon 70 minus summation fi ui I running from 1 to 7 whole upon 70 whole square. You can very easily evaluate this sum, keep it over here, get your variance and then take the positive square root of it to get the standard deviation. And that completes my discussion over the questions. That's it from my side. Thank you.